Hello everyone, in this video we are going to see the introduction of signals and systems and general classification of signal. The contents are signal introduction and general classification of signals. A signal is a phenomenon which carries some information. Some of the good examples are music, speech, still photographs, or biological signals like ECG, EEG, EMG. Those are some of the good examples for signal. Mathematically, a signal is defined as any physical quantity which varies with respect to one or more independent variables. Based on different conditions, the general classification includes three different categories. The first one, depending on the number of sources, then depending on the number of independent variables, then with respect to the nature of independent variable, whether it is continuous or discrete. Depending on the number of sources, the signal can be classified into two groups, one channel signal or multi-channel signal. One channel signal is the signal which is generated by a single sensor or single source. Example is temperature measurement of a room. If we measure temperature in a room, so if we have only one sensor, so such signal is called as one channel signal because the information is coming from only one source. Then multi-channel signals, we have multiple number of sensors. Example is our electrocardiogram. So while taking this ECG, there are 6 different sensors placed around our chest. Then information is obtained from all those 6 sensors. Then we are getting this ECG signals. So here the information is from multiple sources. Hence this kind of signal is called as multi-channel signal. The second category is depending on the number of independent variables. Say for example, if any signal is represented as x of t, here x is the amplitude or the name of the signal and t is the independent variable. Here we have only one independent variable which is t, time. Hence this is called as one-dimensional signal. Example for such signal is given in this picture. Here in x direction we have t, in y direction we have the value of x. The amplitude of x varies with respect to only one independent variable t. Hence, such signal is called as one-dimensional signal. If we have two or more independent variables, then such signals are called as multi-dimensional signals. One such example is this grayscale image. Here we have x-axis, y-axis. We have two axes, one corresponding to x direction, another corresponds to y direction. With respect to the different values of x and y, we have different amplitude values. Then we have different amplitudes at different locations of x and y. So this makes a two-dimensional function f of x comma y, which is exactly a grayscale image which we are dealing with our digital image processing. So any grayscale image is a good example for two-dimensional signal. If we consider a color image, there will be 3 different planes. One belongs to red, another belongs to green, and another belongs to blue. So R, G, B components. In any color image, we have 3 different components. So along with 2 dimensions, that is X and Y direction, we have the third dimension which is Z because we have 3 different layers. Hence, such color image are called a 3-dimensional signal. So if we look at this animation, along with this RGB component or along with those 3-dimensional color image, we have one more feature or one more independent variable got introduced, which is t. Based on time, we have different frames. So hence, along with x, y and z, we have t for this animated video. Such kind of video or animations can be classified into a 4-dimensional signal. Put together, this kind of signal is called as multi-dimensional signal. Then depending on the nature of the variable, independent variable, the signal can be classified into continuous time signal or discrete time signal. The continuous time signal is otherwise called as analog signal because here variable t continuously varying. If you look at this signal, here we can take amplitude at any instant of time. So we can have if t equals to 1 here and if t equals to 2 here, we can take infinite number of samples between 1 and 2. That is, the amplitude is present at all the time. That gives the nature of this independent variable, which is continuous. If you look at this signal, only samples of these signals are taken here. So here the time instants are sampled. Hence this is 0th time instant, this is first time instant, this is second time instant, third, fourth, and so on. So here n represent time instants, samples, sample numbers. Hence such signal are discrete in nature, hence such signal is called discrete time signal. So in general, x of t is continuous time signal and x of n represent discrete time signal. Here the independent variable t is continuous, here the independent variable n is discrete in nature. With this, we can conclude that the general classification of signals includes depending on the number of sources, depending on the number of independent variables, and depending on the nature of the independent variable, whether it is continuous or discrete. Thank you.